So today I'm going to look at this FNIRSI LC1020E, which is a handheld LCR meter. Standard form factor by the looks of it. As you can see, I haven't opened this up yet, it's still sealed. So I'm going to be exploring this thing together. This was sent to me for the purpose of review at no cost by FNIRSI, just to be clear. Usual disclaimer, I will give my honest opinion though. That's what I do. If I like something, I'll say so. If I don't like something, I'll say so. If I think there's things which could be improved, I will say so. Folding front, just like that. Here's the meter, packing list, usual FNIRSI QC tag thing. Got a shorting link here, don't lose that. We've got some PVC leads, 2-wire leads, USB-C to USB-A cable, manual, and in here are nicer test leads. So let's be doing a 4-wire measurement using these leads. So you can be able to do 4-wire or 2-wire depending on what you're doing. It's got this protection sleeve over this as well because that's basically circuit boards. So there's a Kelvin clip, guard, low and high current. Got some gold plated leads. They look okay. Quality looks alright. Proper 4-wire connection, so that looks alright. So there's the actual unit. So you can see they've got the slots there which this connector will go into. Guard to guard over there, so it goes that way around. Hopefully it will only go one way. It'll only go one way, so you can't get that wrong. That's good. So you've got the 2-wire terminals as well with the guard. If you want to use that too, but if you're using 2-wire measurements, guard's almost pointless. If you're using wires, like some nice Pomona shielded cables or something, maybe it's useful for that. Yeah, like the branding on it, so don't know. So you've got a charging port on the side here, USB-C port as expected, tilting bale as you would expect. That's actually nice enough. Not sure about the... My desk is quite slippery, so things do want to walk away. There is actually a rubber foot, but it still wants to walk away. I mean, that's really common. Well, most things that I test that you've got a tilting bale on them, on this desk, they want to walk away. It's just the surface is too smooth. Not surprising. Once you've had a look at the box and the manual, then we'll power this thing up and have a close look at it. So here's the reason I want to look at the box first, because you can see all the main features of this thing. So it does 100 Hz up to 100 kHz, which is nice. Accuracy 0.3% claimed, so is it that way? I don't know. We'll see. I'll do some tests on some of my standards and things like that and see where we get. Internal bias 0 volts to 0.5 volts. Test levels here up to 0.6 volts. You can do calibration obviously, which is quite normal. It's not really a feature. It's something you have to do. Language setting, brightness, sound settings, whatever. It's all there. So we'll get the boring bit out of the way first. Let's have a look at the manual. As usual, have a look at it in your own time. You can pause it if you want to look at any particular pages. I'm not going to read it. I'm just going to flick through. If you want to read something, pause it. This will probably be available online anyway on the FNIRSI website. In fact, I'm sure it is available on the FNIRSI website. There'll be links down below for the manual and to FNIRSI's site for the product and maybe purchase links. I may or may not have commission links. It really depends. Choose if you want to do a commission link, which gives me a bit of a perk or not. It's your choice. You can upgrade the firmware. And there's specifications. So although it says 0.3%, you got 2% on these. That's 2.5 there, 0.6 here, 0.4 there, 3%, 5%. Where does it get this 0.3% basic accuracy from then? Because most of those don't meet that. Is that his... Yeah, I don't know. Bit of a bold claim, is it, to say 0.3 when actually... Blind info. Right. That's the manual. Put it away. Well, the problem with trying to review an LCR meter, there's a lot of things to test, and it's a bit hard to try and cram it into a video. So, auto modes, sub modes, hold, speed, ranges, frequency, level, offsets, and obviously cursor controls here. I'm guessing, I don't know what that is. It's rubbery. Maybe it's a indicator light of some kind, I don't know. Power button. Here we go. Screen's coming on. Screen is up. We'll look at settings and stuff, I guess, are in here somewhere. Here we go. Here's settings. You have to hold the button down. Brightness appears to be all the way up already. Yeah. Maximum brightness. Now, problem is, because I'm recording video, I've got really bright lights here, and so it does tend to be detrimental to the screens when you're trying to record video and trying to show what these things can do. It's calibration in there, system information, there we go, version 1. I don't know if there's a firmware update for this thing already or not. Not sure. No. How do I go back? There's one choice here, restore. Hold it down. Okay, that's intuitive. Calibration, I'm not going to mess with that right now. Off time, no. So, automatic off time. In case you leave the thing powered up, I'm going to leave it on 30 minutes. Just a safety thing. Language, I'm not going to change that. Sorting option. So you can set this up for sorting. So if you want to do lots of components, you try and sort them all out, to like bin them or something, you could configure this to set up tolerances and what have you, just to make it a bit quicker potentially, I suppose. Yeah, holding down, let's get it out. I was correct. Modes, let's have a look at this. So auto mode, which is what I think is in right now. See auto here, and auto there, and auto here. Okay, confusing? No. That must be auto power off, auto ranging, and automatic modes. That makes more sense. Okay, so we're going to do resistance, capacitance, inductance, and if you want to do sub modes, you can push the second one, depending on what's appropriate for the device you're trying to measure. Like for capacitance, I mean R, here be ESR, and we can do frequency here. So push the frequency button. There we go. Scale for frequencies. Default to 1 kHz. Let's put 100 Hz. That's the frequency I like to use. There's an offset there, which can be a good thing to have, but if you're testing things which are polarized, it could be problematic. The other way, I've got these labels down here. They actually match what's on screen. So level and amplification, offset and bias. They're not wrong, they just don't match. Yeah, you probably can barely see it on screen there, but each one is being highlighted by this when I push the cursor around, which means you can probably use it with these as well. Same thing, instead of use buttons. I suppose it's like a shortcut of these buttons, I suppose. But this one here means you can manually range it. So lowest range is 100 ohms. It's not much for an LCR meter, actually. I thought an LCR meter would be lower than that. Anyway, we'll leave it on auto. Let's hook up to some things and do some testing. I do have standards. Yeah, I mean, measurement standards. I should probably rephrase that. I do have standards too, but I have measurement standards, which means I can actually hook up to test capacitors, inductors and things like that. So we can do that. So something that's included in this is this little shorting bar. So you should be able to plug this in, and I'll short that out. And so that's what you use to do calibration. So right now, with that in there, we're seeing zero resistance. So that's what we'd expect. So I don't think I need to do a calibrate for the short. I think that's fine. Now we could use either test leads, or we could use the 4-wire measurement. I'm going to use 4-wire measurement. And I'm going to hook up these standard capacitors here. Now because this thing doesn't weigh very much, it's going to get pulled around a bit by this cable apparently. So we've got 200 picofarad right here. 4-wire measurement straight into there like that. Let's see what we get. Now these terminals might be a bit oxidized, they might need a bit of a clean up. Seems to be having trouble measuring that. Now I'm in manual capacitance mode. Let's try a different connection. Yeah, this is having trouble with this particular part for some reason. I wonder why that is. Let's just try something else. Let's plug this in here directly. Oh no, I can't. Spacings aren't standard. Look at that. Those aren't 19mm apart. which means you can't just plug in a cable, which is what I was going to do as well. Tape measure, close enough. That is 22 millimeters apart. Who decided 22 millimeters is good at design? Design fail, so I can't just plug in my existing cables and test things into this. That won't work. So that's annoying. Back to this. Didn't measure the 200 picofarad, so let's try another one. This one is 1 nanofarad. Can it measure this? Seemingly no. Okay, let's try turning off his biases, increase the level. No. Faster update might be better. Well, it can't read a 1 nanofarad either, for some reason. This isn't looking very good to start, is it? 20 nanofarad. It is kind of reading it. Interesting. Let me change frequencies. 1 kilohertz is more stable. 10 kilohertz. 100 kilohertz. Yeah. Try these again. 1 nanofarad. Now I can read it. Other LCR meters I've tested, 100 hertz can read these capacitors. They're still measurable. 1 kilohertz can read it. Okay. So it looks like 1 kilohertz is basically the speed it wants to run at, because it's not liking anything else. Looks like it's slightly out as well. Now my reference here has got 1.06 nanofarad at 10 kilohertz written on it. So we're slightly off there. Let's try this 200 picofarad one again. Now to change frequencies. Still can't read it. Frequency again. 10 kilohertz, now we can read it. 202. Well, I know that's 200, basically bang on. Right, let's try the 20 nanofarad cap. See what this one does. So 20.05, and on this one at 10 kilohertz is basically bang on. And on 10 kilohertz now, so it's reading slightly high again. Not much. And let's check this 1 microfarad cap. That's looking really good, that one. That's basically bang on. Let's change frequencies again. 100 hertz. It can read it. So it seems a little bit finicky about the frequency versus the capacitor you're trying to measure. So reality is you're probably going to be using this for doing things like measuring electrolytic capacitors. So you're probably measuring, 10 microfarad or 100 microfarad or whatever. So let's get a 1000 microfarad here. Let's whack this on it and see how this one goes. So it's reading that fine. 100 hertz. 1 kilohertz is also a pretty standard frequency for measuring electrolytic capacitors and stuff. It's like the official frequency, but I tend to use 100 hertz because I find it more telling, I suppose. If you see a bad result at 100 hertz, then yeah, you got a problem. But yeah, I don't know. It's working. Let's just look at ESR. I might do a comparison with another meter in a second, and I'll just tell you what it thinks of it. So let's do ESR. So that's what it's measuring at 100 hertz. Let's get my other meter here on, and I'll just tell you what this one measures. So that's 1026 with 0.246. Let's change modes. Make sure I've got the same settings. Yep, it's all exactly the same. Apart from the level, this one's got a level of 2 volts instead of 0.6. This is measuring 1.031, so very close. And the ESR is 0.237. Again, very close. So it's actually not too bad. Now let's actually test it with another thing, which I've got here, which is an LCR tweezer. Because this is also very accurate. This works very well. capacitance. Just put the capacitor. So this is a 1 kHz, 966, 188 milliohms. Okay, 100 Hz, same frequency. 1027, again very close, and 204 milliohms. So this also agrees with this. So it's ballpark. It's actually looking at least relatively accurate. So that's good. So here's my decade inductor here. Currently got it set to 0. We'll see how this handles that. Right now it's looking about right. So let's do 1 millihenry. And we are indeed getting 1 millihenry, just about. It's a bit noisy and erratic though. There you go, 5. Yeah, it's there, but again, it's a bit erratic. 9. Yep. 10. 50. 100. It's looking a bit out. 100 again. 500. So 1 Henry basically. So same thing there. 100 or 1 Henry. There's 3 Henrys. 5. 9. 10. So 10 Henrys is there. We've got a little bit of an error there, but I mean it can do it. It's not looking too bad. Let's try change the frequencies here. You probably won't like it. Yeah. Basically, the louder frequency the better it is from these things. But it is at least doing kind of what I expected to be doing. I mean, there's 400 there again, but again, it's out by a bit. I mean, it's probably close enough for most situations. I don't really think it's that big a deal. Anyway, that's inductance. And here is a 6-decade resistor. Again, this is a high precision part. Very accurate. So, currently set to 0. You're getting basically 0. So, 1 ohm. Looking pretty good. 5. Yep. Not too bad. 10 ohms. Yep, that's looking pretty good too. I mean, there's a bit of error there, but it's pretty good. Let's do 50 ohms. Yeah, okay. 100 ohms. Yep, that's looking very good there. 500. Yep, slightly off, but not bad. 800. Yep. 1K. Yep, very good there actually. 5K. Not bad. So 10K. Let's move this over here a bit maybe. Rejig the setup a little bit so you can see what I'm doing. Alright, so 10K, again not looking bad. On some units, when you change speeds, you actually get more resolution or less resolution depending on what you're doing. So a faster speed usually results in less resolution. But this doesn't seem to be changing resolution, just makes it more noisy. Resolution stays the same, but it gets noisier. So you're not quite sure what's going on there, are you? Anyway, back to medium speed. Yeah, 50K. It's not too bad. 100K. Jumping around a bit there. I don't know if changing these levels will change anything here. Make it more stable. Doesn't seem to be. Biases. Don't seem to. Okay, well. Jumping around's not great. 500K. Yeah, it's really happy, is it, about that? Having that level slightly higher does help. And 1 meg. Yeah, I really don't like how noisy this is though. Now that could be my environment. I do have a lot of noise in this environment. Now if these spacings on these terminals were the correct 19mm 3/4 of an inch spacing, I could plug my shielded cable into this with the guard and hook it up to this correctly, so this is guarded and everything, and get more consistent results. But they're not, so I can't. And just as a verification, I've clipped the test leads together to give a short, and we are indeed getting 0 ohms, as you'd expect. So that's all fine too. One thing I should actually show, which I haven't shown yet or even commented on, when you've got these split terminals like this, you can plug components directly in to test them. Like I've got a capacitor just here. You can plug this straight in and measure it directly, which gives you the most accurate readings usually, because you're not relying on cables and stuff to usually get better results. If you can plug them straight in here, you get a more accurate reading. This is a 33 microfarad cap. It's pretty close. We haven't looked at these cables. I'm not going to either. They're just standard multimeter cables, PVC, nothing special, nothing really to see there. Yeah, they're just box standard cables. Nothing to worry about there. Ignore the stuff in the back of the desk, other projects. So let's pull this thing apart and have a look inside it. So apparently it's got a 3000 milliamp hour battery in it. This screwdriver is not gripping very well. Must be the wrong bit. This one? Yeah, it's better. Yeah, so it's got a 3000 milliamp hour battery apparently. So, which we'll see if that's correct. I expect it is. I mean, whenever I looked at any other FNIRSI products, the battery capacity has always been real. So I've never had an issue with it in the past. It's not that I recall anyway. Other products, which I think were wrong, but kind of stuck. Right. Okay. There's a battery, 3000 milliamp hours. That's true. No issue there. Let's unplug it. Have a close look at the board. Not much to see there. There's the input jacks on a little sub PCB. So these are the split jacks. So that's the guard, and that's a split jack, and that's a split jack. So it basically connects this side to that side when there's nothing in those jacks, or when you've got the probes on there, it's giving you the 4-wire connection. So 2-wire comes with that side, and obviously you can't see all the other traces because they're on the other side of the board. So you've got some op amps and stuff down there, I'm sure. Try and get the light on different angles so we can see things. Here we go. Here's some numbers. I'm not going to look at all these parts. I'm just going to look at what we can show you, in case it helps. CH444, interesting. Don't know what that is. There you go, more parts down there. 4056A, cool. It's a charge controller for the lithium cell. There's a little buzzer, USB port, and there's a little reset button just there, which I didn't notice on the outside. There must be a hole there. Right, there's a hole. And the controller has been lasered off, but you can still see something there. There's still some text there. Can you see that? There's definitely something there. You can see some kind of impression. Can't read it, but there's definitely something there. Trying to get light on a different angle. Sometimes you can reveal things from that. So yeah, flexing off the display. Nothing too exciting in there really. Sort of stuff you'd expect to see. Bunch of amplifiers and op amps and sensing circuitry and what have you. So yeah, let's put it back together. So what's my opinion of this thing? Well, it works. Accuracy seems reasonable. I'm not sure about how noisy it is in some of those readings. I think they could have been a bit better than that. I haven't really noticed that much noise in other LCR meters I've tested. Also, for your information, I've got other things I'm doing reviews on. I've got this soldering iron, which I'll be doing a review on soon as well. And there's also a power supply, which I've already recorded a video for. I think it's going to be maybe released next week. I think it'll be next week I'll be releasing that one. So watch out for that too. It's a brand new power supply, new on the market. It's not out there yet. I've actually got one of the preview units. This power supply here. Thanks for FNIRSI, send that to me to have a look at. And if you're interested in having a look, I've got a cat hair stuck in there. So if you're interested in looking at these things, check out the links down below to FNIRSI's site and the purchase links and whatever that's down there in the description. Other videos to watch down below. Subscribe over here if you want to subscribe. You want to see more review videos and things like that. I specialise in doing repair videos, so that's what I really like doing, is electronics repairs. So if you want to see those, if you've not seen my stuff before, maybe check those out. There's also a Patreon support link over there if you want to help support the channel, become a supporter. There's also memberships and one-off donation links down below there on the YouTube side of things too. Patreon is what I recommend if you want to help support the channel, because you also get perks like manuals and firmware and things like that I can attach to files as well. Can't do that on YouTube. Catch you later.